All right, friends, welcome back from that activity. How'd that go? How did you guys do? Did you learn quite a bit? You guys did really well looking just at all the questions that you asked. Was that helpful? Did you kind of feel comfortable diving into the material? Cool. Yeah, awesome. I'm glad it was fun for you. Okay, so we're kind of entering the last part. I know, Cameron, I feel that. You said your brain hurts. I get that. Uh, and part of this too is you diving into the material and learning more about it. It's just a way for you to learn, right? I could, in theory, just sit and tell you everything here, but I mean, nobody really wants for me to sit and talk for 8 hours. And so that's just a way for you to dive in because it's easier and better for you to understand. There's a lot of science behind, I'd heard a quote. I don't know how scientifically accurate this is, but it was you retain 10% of what you hear, but 90% of what you figure out for yourself. I'm sure that that's a little bit skewed, but it's this idea that if you are diving into the material, you will have a better understanding other than if I just had a million slides that walk through everything. So kind of what we're going to be doing for the rest of the day is we're going to go through this pub trivia. And then really after that, all we have is kind of clarifying any questions that we have. I'll tell you kind of next steps. I'll show you the practice exams that you guys can take. I'll show you the next steps, kind of tell you what's coming forward, how you're going to do this and hang out for there. And then, answer any questions. So we're kind of entering the last aspect. I would assume we're probably going to be done within the next hour. But we can take up as much time as you need. We try to not hammer it until 5 o'clock because we understand that this is a lot of material, especially for this AZ-900. It's a lot of material, like a lot of material. And so, your brain will be fried usually about 3 o'clock-ish Pacific time is when we notice people are like, man, I'm just tired. So, yeah, so that's kind of what we have coming up and moving forward. What I would like to do is you guys asked some really, really, really solid questions. And so we've got some time. The next piece, the kind of what's next is about 15 minutes. So really, I would like for each group to maybe spend 10, 15 minutes at max, 15 minutes max, but really 10 minutes. And, if a couple people want to share what they understood and what they learned, that would be awesome. Also make sure that you put your name. It doesn't have to be associated to the particular question, but put your name on the sheet with whatever group you were in, first and last name, because this is what I will be using for an attendance sheet. So please make sure you do that as well. If you need this sheet one more time, I'll put it here in the chat for you. If you already closed it out, forgot to do that, it's now in the chat. And again, you guys are going to be receiving this sheet. Tomorrow, I'll be sending this entire folder to you. And so that way you can have all these questions and all these answers. If you got to a point where you forgot to answer a couple of them or you're still working, I know I pulled you in like 4 minutes early. Feel free. You're going to have access tomorrow. Feel free to go back in and edit that. But you guys can use this as a tool to study for the exam. Cool. Does anybody from Breakout 1 want to share what they've learned? Again, you got some time. You got 15 minutes as a group. So anybody want to share something really neat that they learned or something really interesting or anything like that? Oh, you guys asked great questions. Somebody step up and ask and talk about it.
Oh, I can go. I did the section on PostgreSQL.
Okay.
I chose that one because I actually do like databases, maybe because I like organization. But anywho, yeah, I since I didn't know about that type of database, you're basically applying, regular Postgres into on a cloud basis. Don't know practically what that looks like. But I've learned about the deployment styles that they have, which was like single server versus hyperscale. What we talked about earlier, whether a client wants to be based on just one server nearest to them, or if they're a larger scale organization using multiple. So example like Amazon, Google, and that's basically it on my aspect of it.
Yeah. Could you actually explain the difference for people who didn't get to read about Postgres? I think it's a great question. What's the difference between single server and hyperscale? Do you mind kind of diving into that?
Sure. So my understanding of single server, so well, first Postgres is a relational database, so a SQL and say structured query language, and it's basically how your database is structured. So say for instance, you have large corporations that need data to be stored in different aspects of it. So when you look on something like Amazon, you have to store the user's information in terms of like their name, date of birth, credit card, and so on and so forth, but also maybe their shopping carts, or maybe you want to store preferences or whatever the case may be, and also on the employee side. So that's what the databases are for. And again, Postgres is relational in the sense that there is a relationship between it, and I feel like it's kind of hard to explain. um so it just has some type of structure to it. At least, hopefully I'm not repeating myself, but it just has some type of structure to it where the information has some type of likeness to it. So again, if you're doing something like a user, they have the first and last name and then address, that's all relational and everything. And then if it's non-relational, it's a different conversation. But an example of that would be MongoDB, and we usually use that in like the MERN stack. And but yeah, it's helpful if you're using something like relational, and it'll be good for maybe like small businesses, because maybe you just only have user information, you don't need a whole bunch of stuff to be stored. So then that may be beneficial for a small business or even medium size. But say for instance you have something large scale like Amazon or Google, or Microsoft, or whatever the case may be, where you have to have not only like the users that use your product, but also employees and also different sections of it. So maybe there's an HR system, or maybe there is maybe talking about like insurance, where they have like a claim section of it. So basically, whatever data that needs to be stored, you need to think about how you want it to be stored. And depending on your response or what the client wants, you would either want it to be a relational database or non-relational database. Non-relational, it's faster. You're just putting data in it, but relational is a little slower. But maybe again, you probably need that structure to a person's business. You can't just put the data anywhere. Hopefully I didn't confuse anyone.
Yeah, no. Let me kind of no way to go. Just a good understanding of that. One thing that you can kind of think about with relational and non-relational database is relational database deals with what we call structured data. Now, if you guys took Python, you probably understand that if you took Flask or Django, whichever one you ended up taking, that you had basically a model in your database and it had different attributes, right? And every model had a different attribute. Now, maybe we had that model have it could have a null value. So let's say a full name, right? Maybe we have a first, a last, and a middle name, but some people don't have middle names. Well, if we allow it to be null, well, then, okay, whenever I save a user within my database, although it doesn't have a middle name, if I were to pull up that row, right, because a relational database is in rows and columns, if I would pull up that row, it's still going to have a column of middle name, just its value is going to be null. And so with a relational database, it's also called structured data. It's basically in rows and columns. You can kind of think about it just like this, right? How there's a column of topic, and then there's row 3, 4, 5, 6. And each row has a topic, a model, an owner, a questions. That's sort of how a relational database works. And then what I can do is I can connect the two. So let's say I have a database of addresses, right? Well, I can just say, well, this address is associated to this user. And so that's where that relational aspect comes in. Versus a non-relational database, there's quite a few different ones, different types. So there's like graphs and cluster columns and just like our MongoDB, right? To where you're reading on a document where you can have some of the same material, right? You can have a first, a last name, a middle name, but not every instance, not every row has to have the same material. So if a user doesn't have a middle name, when it's saved in there, it's not going to save for middle name. It doesn't have to have that column. There's just kind of a first and last name, and it's written in like a JavaScript object, which is JSON, right? And so that's sort of how it's written. So yeah, way to go. I think you explained it really, really well. Cool.
Yay.
Wesley, Chris, Samir, anything you want to add to something you learned?
Yeah. I was I read over the managed instance for the
Mhm.
SQL. And it was kind of, it was a lot of different terms that I wasn't, sure about. So I had to look up a few things. Like it was talking about a virtual VNet,
Machine.
a VNet. I'm sorry, what was that?
No, go ahead. Let's open it up. Just boy.
Yeah, so there was a few things. Native virtual network, that I had to like kind of research about. And um, so with the managed instance, it allows people that are like transitioning from a local SQL database. These customers can migrate into their apps into a cloud environment, from the on-premises to the cloud environment, easier with the managed instances. And it has certain features like, I think service brokers was one of them, and they can send they can have database emails.
Okay.
So the database can send emails depending on when do you tell it to send specific emails directly from the database. It was definitely a lot of information for this section.
Sure.
So I kind of still kind of foggy on it. But that's what I gathered from the readings.
Yeah, no, I think that's great. It's a type that you can do. It's just a process that you can take your on-premise SQL database and you can put it to a managed instance that can do, specific things. This is where that how we were talking about how different organizations within your company, um, how different organizations within your company might use different things, right? If you are migrating your database and maybe there is an aspect where you want to send emails, you might see this tool and say, oh, this is a really great tool that I want to use within Azure, right? And there's different things that you can do. You can use the migration tool to do a managed instance of this. There's other SQL tools, as you can see with the Postgres and Cosmos DB. there's different tools, and this one just this one covers and supports more niche things. And again, that's where the cloud is coming. And that's where it's really at its best, is that each cloud provider has different applications and different tools, like a SQL managed instance that might fit exactly what you are looking for. So yeah, it is one of those things that, especially if you're newer to databases and especially the cloud, really diving in at the beginning is going to seem a little bit more overwhelming. But if you enter Coding Dojo without any sort of coding practice, then you probably felt the same way about development, right? Or Python, and when you learn a new language. And as you start diving a little bit more into this different, these different things, then it'll become a little bit more, you know, not self-taught, but a little bit more clear. But no, way to go. I think that's awesome. You did
Yeah, I
well.
agree. I agree with everything you said. Yeah, thank you.
Yeah, of course. Way to go. Cool. Number 2, breakout group. Anything else from breakout room 1? Are you guys pretty good? Cool. Anybody from breakout 2 want to share something?
I went over the Azure HD Insight. I can definitely talk about it for a
Yeah.
sec. It's not quite as robust as what we were just talking about,
Yeah.
but it mostly is like a big time big data analytics tool.
Yeah.
But rather than like having to deal with like, the pricing and sort of the roadblocks of putting a whole bunch of data through analysis, it sort of functions in a way that puts it like it's like scalable, so you don't
Mhm.
have to. It tends to be like cheaper, it seems like. They have like some cool ways of clustering data to store costs, or
Mhm.
to scale costs, like pricing tiers, things like that. But it also seems like they make a pretty big deal out of, there's like seems like a pretty big like open source ecosystem that it interacts with.
Mhm.
It uses like a bunch of, some that I've heard of, but quite a few that I haven't heard of, that I guess people use to like manage their data, that is like compatible with these analytics. Yeah, kind of just putting you in a position to like process large amounts of data like pretty quickly and efficiently.
Yeah. Yeah. When we, great job. HD Insight is one, especially like in Synapse. Those are some that are really big with handling mega amounts of data. Not just little, kind of little portions, but if you wanted to do some sort of like machine learning or doing some sort of, you have this massive data lake and then you need to process it to do something with that, whether it, you have a machine learning model or you need to send it to your analytics for something like a data analyst to like, you can think of Nordstrom as a local company here in Seattle. Obviously everybody's heard of Nordstrom, but they have the Nordstrom sale, right? Every year, some big sale in like July or something that I guess a bunch of stuff's on sale. I don't know. A good friend of mine works for them. And what she does is takes in the data that, of what they did and helps, then they run it through a model and forecast for next year. Right. And so if you were taking, I mean, that is probably still not enough data, but if you're taking all this data, what you can do with HD Insight and Synapse is to take this large amount of data, do something with it efficiently and much quicker than, if you were to go line by line, something like that. So yeah, it's just a tool to help manage that. And then, yeah, there are some, and that's something to note is the cloud. There is an entire ecosystem with the cloud as well, where people use tools. Like one of them in the data science is Apache. And so you can use those different tools within the cloud. And then there, people have built tools to interact with maybe a tool on, Azure. So maybe the exact thing, the exact application that Azure has, maybe, does 90% of what the company needs. Well, maybe they will have some of their developers create a tool that gets that extra 10%, right? And then it becomes more popular. It's open source. So yeah, way to go.
Cool.
Anybody else have anything to add from group 2? Anybody want to talk about a data lake or a data brick?
I did some research into the data bricks. I can talk a little bit about that.
Yeah, go ahead.
So the way I understood it by reading it was that Databricks is kind of a way to prepare a lot of the information you're gathering, and the data brick itself is a unit of processing capability per hour, I believe, that's scalable based on how long and how much information you want to process, and it uses a lot of the Apache frameworks and engines, and is easily integrated with a lot of other Azure platforms. So that's kind of what I understand so far from it.
Yeah, no, exactly. It's a way to kind of handle data as well. Exactly. Way to go.
Thank you.
Cool. Anybody from breakout room 3 want to talk?
Yeah, sure. I can go ahead with. I did a lot of virtual machines, so I asked those questions. How does Azure tie with VMs, and when are VMs used? So Microsoft Azure allows us to create virtual machines in cloud. So anytime you're going to use cloud, you're creating a virtual machine. Just like your physical computer, you can customize the software on the VM within Microsoft Azure Cloud Services. And then the next question I had was, when are they used and what examples of why do we use them? When running applications through cloud, a Microsoft VM is configured and used. VMs are used to test and debug code, as well as they extend data centers, and they're used for disaster recovery in case data information is lost.
Yeah.
And then, and then like machine scale sets, that's something I found interesting, how you can create essentially stacking all these virtual machines together and scaling the sets and being able to manage all the data and update everything at once. Or at least done in a few minutes.
Yeah, so like a virtual a VM scale set. Could you talk a little bit about that?
Yeah, sure. I'll go. So as I understand it, virtual machine scale sets let you create and manage a group of identical load balanced VMs. Scale set allows you to centrally manage, configure, and update a large number of VMs in minutes, and provides essentially a high capacity for high available applications. It can run a lot.
Yeah. So, and thank you for that. I appreciate it. Because this is something important. Remember when we talked about the scalability aspect, right? if I've got something happening and I'm handling a lot of traffic, what a scale set allows me to do is basically make an identical virtual machine. And then when I need to scale horizontally, right? My scale sets allow me to do that wicked fast and very easily. So scale sets are great for scaling horizontally because what I'm doing is I'm not increasing the capacity of my RAM or my CPU from like a vertical standpoint, right? I'm not just going to that one virtual machine and giving it more power. What I'm doing is I'm actually able to mimic and copy my virtual machine and scale out really quickly, like you said, within minutes, to where now I can handle, if I get to some threshold and I need, 2 virtual machines, it's like 2 computers working for me, and then I go to 4, and then et cetera, et cetera. So
And then the scale sets allow you to configure them all at once too,
Mhm.
right? Instead of having to do each individual one, it just
yep,
takes it
it's like a copy paste sort of thing where you say
Yeah.
this is what I needed to do, and then it scales out. So it's really a cool tool for scaling horizontally.
definitely.
Cool. Way to go. Anybody else want to talk about containers or Windows Virtual Desktop?
Good
I mean,
question.
Go,
you can go for the question.
Oh, okay. Just for clarification purposes, when you mean scaling horizontally, vertically, could you, because when you mentioned it earlier, I was having still a hard time.
Yeah.
So could you mind like you briefly going over that a little bit?
Yeah. Yeah. So one of the benefits of the cloud is that we can scale very quickly. And what that basically means is I can do one of 2 things. I can scale vertically or I can scale horizontally. Now, what does that mean? Let's say I'm an organization and I am taking in data and I'm having this intense machine learning model that needs a lot of power. Well, I have 2 options. One of them is I can scale vertically, meaning that instead of, let's say I set up my virtual machine and we just think about it like it has 8 gigs of RAM, let's just think about it from a RAM perspective. It has 8 gigs of RAM. Well, let's say all of a sudden I have a lot of either traffic or I'm trying to do something heavy where 8 gigs of RAM is not going to do it for me.
Mhm.
What I can do is quickly, by the click of a button, or if I set it up to be like a trigger piece, I can add and make it now 16 gigs of RAM very quickly, right? I just say I want to allocate this much RAM to this, or I can make it 32 or 64. Now, if I was doing this on premise at my own, place, well, if I needed more RAM, I'd have to go out, I'd have to buy more RAM, and then I'd have to add in my RAM, right? It's like a whole process. Where on the cloud, I can just basically go and say, this is how much RAM I need. I get charged. And then once it's done, right? Once I'm done with that, either a lot of traffic or I'm done running that model, I can scale back down to the 8 gigs that I have. So that's vertically scaling. You can do that with CPUs as well. Horizontal scaling is kind of like what we just talked about. Let's say I've got an 8 gigabyte of RAM machine computer, right? And that is my, we can kind of think about that as that's what my application is running through. Well, let's say it's Black Friday, right? And I am a clothing company.
Mhm.
Well, I know that I'm going to have a ton of traffic to where maybe adding RAM is good, but I don't want all of my traffic going through one, right? What I can do is I can also scale horizontally. And horizontally is like now, instead of all that traffic going through one 8 gigabyte of RAM computer, now I have 2 or 3 or 4 8 gigabyte of RAM computers all processing. And so that's called scaling horizontally. So it's not that you're increasing your RAM to one machine. It's now you have 4 machines doing the task, or a load balancer, which sends it,
Oh, okay, I see.
one. Yeah. What a load balancer will do is it'll take a request and then it will send it to the most optimal virtual machine, basically. So it's hosted on 3 things to handle traffic. But if I need to, let's say it's Black Friday or, it's Amazon Prime Day. If I need more machines, I can use a scale set to basically copy and paste my current virtual machine. I don't have to go in. I don't have to upload it. I can just copy and paste and scale out to maybe now I have 6 machines. Does that make sense?
Yeah, so vertically is more about what you said, like, so you're still using one machine, but you're increasing the amount of memory that machine has, as opposed to horizontally, you're getting more machines and spreading out same amount of memory still, but it's more machines. So here's vertically more memory in one machine, and then horizontally more machines, but maybe the same memory.
Yeah, so you can think about it like vertically, it's like you have one mega machine, right? That has all beefed up, but it's still one handling everything. Versus horizontally, you've got adequate machines, quite a few of them, and you have a load balancer saying, okay, machine 1 is already kind of, at 80% capacity. Machine 2 is at 70% and machine 4 is at 25%. I'm going to send it to machine 4. I'm going to send this request to machine 4 to handle this because it can. And so that's where like scaling horizontally
Gotcha.
really comes into play.
Thank you for the example.
Yeah, of course. Cool. Yeah, virtual machines are cool. Windows Virtual Desktop, just to kind of talk about that one. That is literally like if I wanted to use Windows, right? So I currently have a Mac, right? That's what I use. But let's say my organization is a Windows company. Let's say I get a job at Microsoft and they're like, you can keep your computer. That's great. But everything we have is on Windows. I can actually just, it's like an emulator, right? To where I can act and rent. I log into and it looks like a Windows machine. It is a Windows machine. So if I have a certain application that only runs on Windows, I can use that within my company. If my person just has a MacBook or a Linux machine, then I can still, but there's an application that we use that is just Windows. I can just spin that up and it's like I'm logging into a Windows computer to run that. Cool. Cameron, did you want to talk about container instances in Kubernetes?
Yeah, I was just gonna do a quick rundown of it because
Yeah, that'd be awesome.
is a lot of information.
Yeah.
Kind of like with the virtual environments where, well, virtual machines where you can run multiple instances of those. With containers, you're putting your program and all of its dependencies in one section or in one container, which you can run multiple on a single virtual virtual machine. So I classify it as like it's a virtualization environment. So you can run multiple different operating systems off of one machine at the same time. Whereas a virtual machine requires just one OS that you can run off of. So you'd have to use multiple to do different programs. Whereas on a container, you could do multiple different OSs, meaning multiple different programs that run on a standardized runtime environment, which means that your scalability per application is much larger than just one virtual machine.
Yeah, way to go. So you can kind of think about it like this. When I've got a virtual machine, right? Here's my virtual machine. Let's say I'm just using that and I don't have any sort of containers. This virtual machine, I'm running everything off of it. And I am tied to this operating system. I'm tied to, kind of what this can offer. Now, when we get into containers, and it's a really popular thing. When we get in containers, what it's doing is I'm actually using this virtual machine, but I don't know why it's not allowing. Oh, sorry. That's why. But now I can actually have this container that runs something, right? I can have this container that runs something. So I'm compartmentalizing things that are all on this virtual machine, but they all are, I'm basically compartmentalizing what I have and they can all act different, right? So this machine is running it, but I can have different tools. I can have different things within each container. So it's a way to separate it. Another big piece of it is, let's say I have an application that I don't need an entire server for. I don't need an entire virtual machine for. And this is like a benefit of the cloud from the cloud provider perspective, but also the user perspective, is instead of me having to pay for this entire virtual machine, let's say I've got a very, very, very lightweight application that I need to run, right? Well, I don't need an entire machine. I don't need an entire server to myself. So what I can do is I can put it in a container. And then let's say that Cameron's got a very, very lightweight application that, he then puts his in a container and now it's running on the same virtual machine, but we have two different applications, right? And I can do that within my own company or outside of that, right? If there's just two random companies, because now I'm not paying for the entire virtual machine. I am paying for my portion of the virtual machine that I'm using. So if I have a really lightweight application, I don't pay as much, right, for using this entire virtual machine versus, just the 20% that I'm using. Containers are cool. And allow, like you said, allow for scalability, but it allows you different things as well, right? And so instead of having to have 6 different virtual machines, maybe I can put it in container, put them all in containers, and then it operates on one.
Yeah,
Saves me-
and one cool thing, sorry to interrupt, was goes into the Kubernetes, which is like an architectural system for containers.
Mhm.
And one thing that I thought was kind of cool was someone proposed the idea that your program has your front end, back end, and then your storage. And they're all running on separate containers. But let's say that your back end was, had reached capacity. There's too much volume going into it. So one thing you could do is, replace that back end portion of it without ruining or affecting the rest of your application, because they're all running in separate different environments.
Mhm.
So you don't have to stop an entire thing or an entire program really to make changes or do specific updates to the front end versus the back end, where you can have certain things stay the same and not be affected if one goes down.
Yeah, no, exactly. Like you can think about it. I think about exactly just like what you said. I think about it from like a front end web framework, right? Let's say you were using, vanilla JavaScript or Bootstrap, and then you wanted to eventually move into something like a React or an Angular or a Vue. That doesn't, maybe it's all built in Java though, or Python or Node.js, right? If I containerize it and I kind of separate it, whatever I do on my front end is not really going to affect my server or my data, right? And so it's a way to kind of compartmentalize it as well, to where if if something goes wrong or if I'm updating or doing something different, it's not going to affect the different aspects of my application. So way to go. Awesome. And the last one, we've got Azure App Service, Cosmos DB, and Azure Functions. Anybody want to talk about these, particularly Azure Functions or Cosmos DB?
Sure, I'll start with app services.
Yeah, let's do it.
It's a virtual machine made for just general front end web apps. And I guess its main purpose is to allow people not to worry about the back end so much, or about the, what we've already learned about. We don't need to worry about the scaling, or we don't, it doesn't need to go vertical or horizontal. App services will just figure that out on its own.
Yeah.
And just go along with whatever's needed as far as the amount of users that are using your app. And it's pretty versatile. It uses you can use a number of programming languages on it, and different hostings. So it's probably one of the main virtual machine applications, like our programs we used in our final projects. You could have used app services for that to load that up pretty fast.
Yeah. That's awesome. Yeah, it's a great tool, right? Where, just like you said, instead of me having to create any sort of triggers or functions or any sort of warnings, app service will automatically scale for me. So it's more of a plug and play, right? And so this is great, especially for somebody like if you guys were starting your own website, or if you were doing some sort of company where you could write the program, but this allows it to scale vertically or horizontally, which is really awesome. So you don't have to have this massive team or this architecture to kind of set that up. So way to go. Yeah, app service is a cool thing. Cosmos DB or Azure Functions, anybody want to talk about those?
I can quickly talk about the functions.
Cool.
It was a really interesting read. It's pretty much just talking about like micro billing and events, which is really huge for applications, right? And kind of like gist of is, one day maybe you're paying for a specific amount like per day, but you get like 2 events, right? Maybe you get like less interaction than you did yesterday. And kind of what functions do and what they eliminate is instead of paying the same amount every time, you're pretty much only charged for the time an event takes to process, right? So again, if it like runs twice a day for like 10 minutes, you would literally only be charged for the execution, I believe, and then how long it ran for.
Yeah.
And it's really interesting because it uses your own code, and it's it makes sense to me because you're not sitting there waiting for input. You're not sitting there waiting for events to occur, and then that's kind of like it takes off the stress of that. So yeah, I thought that was really interesting.
Yeah. Azure Functions to me is a really fascinating thing. And it's Azure Function is what it's called here, but there's serverless on all, again, these are like kind of core cloud concepts. But just like you said, my friend, it is a time where, kind of going back to what we were talking about of the containers, right? You got this big virtual machine, and then we talked about how there might be some sort of like containers there, right? And we're saying, oh, don't pay for the entire virtual machine, you just pay for this portion. Well, what functions really come in handy is instead of even paying for this portion, that, if you're paying for this container, you're paying for this 24/7, right? Even if traffic is low, even if there's not a ton of people coming to your application, you're paying for this, kind of portion of this virtual machine. With an Azure function, it is, like you said, there's a trigger or an event that basically triggers this function, and it spins it up. And once that is triggered, it goes and it runs an amount of code that you have decided for it to run. It runs that code, and once it's done running, it is off the virtual machine. And all you're charged for is when that is triggered and the amount of time it takes to run that code and do whatever you told it to do. A great example would be, I was just having a conversation with a friend a couple of weeks ago, and he's the CEO of a company that basically is they have like a wearable technology. And so they're really big with like Amazon's their customers. So Amazon warehouse workers, they wear their material, and it's a way to keep them safe, right? And so if it uses it uses machine learning, and it uses a bunch of stuff to see, did they fall over, kind of like how Apple Watch can indicate if you've tripped or something, if you've fallen over, same sort of technology. And what it will do is, if that is, if they are falling over or in a precarious position with their body based off of their wearable technology, that will actually trigger a function that gives an alert that that, hey, this person has been like this for the last 2 minutes. Here's their location. You need to go kind of check on them. And so that function, that alert, is only ran if a user falls over or if they are hurt in any way. And all his company pays for is when that function is triggered, it runs the code, it sends the alert, it processes, it gives the information, handles all the information, sends it out, and then it stops running. So it's just a function. You can kind of think about it, if you're building your technology, you're only paying for however long that function takes to run versus paying the entire time. It's a really cool thing that allows you to really cut down your costs. Another big one would be like if you are doing, if you're getting the prices of a stock at midnight every night, right? Well, you don't need to use an entire virtual machine for that, but maybe your application wants to just run that at midnight. You pay for however long it takes for you to do like however your application crawls the web and gets that information. And then once it's done running, you're done paying for that. And maybe you can send it out or something, some sort of information. Make sense? Anybody else have anything that they want to add?
I can talk about Cosmos.
Yeah, please do. I love Cosmos.
So Cosmos DB is essentially the DB to end all DBs. You can utilize information from different services. For example, if you have a DB in MySQL and another in MongoDB, you can upload them both to Azure Cosmos, and it will allow you to use all that information. It supports multiple data models and many APIs. It's very, very useful, and it's also very fast. It's common in mid to large scale companies because you're able to scale so quickly. And its uses include in gaming applications, web applications, anything you can really think of, you can use Cosmos for. Plus their relationships with, it's a NoSQL database in particular. So the relationships aren't bound by a rigid structure, which allows people to use it for user-generated content, such as tweets and IMs, a lot more fluidly than other databases would allow.
Yeah. I love Cosmos because it is a fascinating, kind of like you said, end all be all. One of the big benefits and one of the kind of use cases is let's say, so Microsoft owns GitHub and it owns LinkedIn, right? And so let's say when Microsoft purchased GitHub and LinkedIn, it wanted a list of all of its users. Well, let's say that GitHub used a MongoDB database, and let's say LinkedIn used a SQL database. Traditionally, what we would have to do is either try to go in and clean all of our MongoDB data and put it into our, kind of SQL structure, or vice versa, right? And I'd have to migrate all of that over, and some of the data will get lost, and it is kind of a pain. But what Cosmos DB does is it allows you to put it all in one database, and then it kind of acts like an API call to where I can then go and retrieve information from that database, to where even if that's why it says, like a medium large size company is, if Microsoft buys GitHub and LinkedIn, it can kind of push them together, and it's really quickly and easily accessible. It's really fast as well, which is a really kind of neat thing, even though those databases aren't the same type. So way to go, Harley. Cool. Anybody else have anything else? Way to go, guys. This is a great. This is one of the best, if not the best, that I've seen. For this, way to really be attentive and really dive in. Anybody else have anything they want to add?
Yeah, there's another question. Would we be able to like see the implementation of Azure? Like how, if whether we're working for a company that uses Azure, or maybe we're, freelancers or contract work, like how, because my understanding is that we are, what's the word? We're learning all the functionalities of Azure, but like when it comes to like real life implementation, kind of curious that, do you go over that, or like how do we learn that?
So I won't, but in this Microsoft, I don't go over that. But in this entire information, I think this is great for us just to dive into anyway. If I were to go, I'm going to type in AZ-900 here. If I were to look at this, here's where you're going to take your exam. We can just kind of segment over to that next one. Here's where you're going to take your exam, and I'll send you this code as well. So the passing score is 700, and you can learn kind of about exam scores here. Here's where you're going to do that, and it will talk about the different ways. So normally you can do a Microsoft Azure Fundamentals 1 day. Now these typically cost around $1,500 to do one of these two. It can be up to $1,500. Typically, I think it's around 12 to 15, which is insane. Or you can do it free, which is through us and by, your own learning. And so through this, these are the different learning paths of Azure, right? And so this one, if I were to dive into here, this is kind of the part one. With this part one, there are different tools and different things that you can do, to where I don't think it's this one. One of these, you actually do that exact thing. So you will build basically a WordPress website on Azure, and you're going to host it. And so it has exercises throughout this learning that will do that exact thing. So let's see. No, but it does. There's exercises throughout this piece to where you can actually, okay, it's in this one, where you can actually utilize and try to do that on your own. But we won't be, but you can kind of think about, again, this is understanding the different aspects of Azure and the different tools and offerings that it has. But with this, you can dive in and kind of mess with it as well, to where you can do some exercises and kind of play with Azure. So like this one is creating a SQL database, and it'll allow you to actually do that. So you learn about it and you will actually do it. But I will not be going over that.
Okay. All right, cool. Thank you.
Yeah, absolutely. Like I said, don't forget to write your name if you were, as long as you were here. Don't forget to write your name in here. This is how I am keeping track. So make sure that, and if you weren't there for that group presentation or working on that, please just let me know via a DM, just kind of what was going on, and then it'd be good to go. Awesome. Well, friends, that's about all I have today. I know that we went through a ton of information. We're going to kind of talk about now what our final thoughts are. And if there's any questions, you guys can feel free to ask that. I did want to let you know that there are practice exams. And so here there is at this test prep training, I'm going to send you this. I'll put it in chat right now. Yeah, exactly. No thoughts, head empty. I know that there's a lot of material, so that's why I'm not going to really dive in. But here's some free practice tests. So this one's 10 questions. I believe it's got a pool of maybe 90 questions, but you can practice these things, right? Practice what we're learning. And a lot of these questions will be similar, if not the exact same, because I can't do that, but very similar to the questions on the exam. The exam's about 55 questions. Just talking about the exam, it's about 55 questions. And you're going to have 60 minutes to do it. It will be a 90-minute. I would plan for 90 minutes in total. It is a proctored exam, meaning that somebody is watching you. You do have to download a application, basically, that prevents you from Googling and kind of cheating on the exam. But that's actually what gives validity to your exam, right? It gives validity to no, this person does understand these concepts because they were not able to cheat. They were not able to look up things. They were not able to do any of that, but they had to just do it themselves. So therefore, a proctor will be watching. Now, if I were you, as you were setting this up, they will, Harley, you asked the question. So off the record, if I were to have a second laptop, what they will actually do is you will have to have a camera. And so, they will have to have a camera, and then they will make you show your surroundings. So, if there is a piece of paper, they will have you, even if they can't read it, even if you said, oh, that's just my child's birthday, doesn't matter. They will turn it. They'll make you move it out of the room. People can't be in the room. It's kind of like crazy. It's kind of hardcore if you ask me. But what I would suggest, and the way to do it, the easiest is like find a space that's not your office. So instead of having to like move everything around your desk, maybe go to a kitchen table. Go to like a kitchen table and, somewhere that's not typically your desk, and then you should be fine. Lisa asked if you can also go to a testing center. I know that they had that. I'm not sure with COVID, if that is a possibility at the moment, but I know that before COVID, you absolutely could go to a testing center. It's totally up to you. If there is one, within your area, then that's awesome. But again, with COVID, I just don't know the offerings that they're offering, or if they're just doing proctored for right now.
Yeah, they do. It's just really, really limited. Like there was basically almost, I have to go to another state or like another part of the state to get it. But yeah, technically, at least in New York, I don't know.
Yeah. Fascinating. Yeah. Again, I think with COVID, the idea of having a bunch of people in a room, they probably have slimmed that down to where like, no, we'll just go proctored. But maybe if there's something around you, hopefully that would be something that's great. You do need to schedule in advance if you are proctoring. Well, also if you're doing it at either one of the centers, but I would schedule in advance. It can take anywhere from, you can be as close as like 24 hours. Usually it's like within 24 hours. There are some obscure times if you work, in the daytimes, they have people that can proctor it, late in the evening or early morning. But yeah, you do need to schedule that in advance. And I will be sending you a voucher code. Tomorrow, I'm going to send you a link with, or an email, sorry, with a link to the workshop, Google playlist. It will be, YouTube playlist. It will be a link to all of our materials, to that practice exam. It'll be a link to this page that I just showed, the one that gets you to the AZ-900. actual exam. I'll show you this link as well. I think Lisa, you just asked for this link. I'll put this in the chat for you. And yes, I will allow you. I'm also going to send you access to all of this Google Doc. So this entire folder right here, this AZ-900 October 2021, you'll have access to. So that way, you know, if you wanted to see your small business stuff, or if you wanted to kind of make up one for a large global business, or if you wanted to access these different things, you can absolutely do that as well. So I'm going to be giving you access to all of this information along with a coupon code. And the way the coupon code works is you're going to come here and you're going to schedule your type of exam. And so Pearson VUE is going to be a non-students interested in technology. So you guys would do Pearson VUE. I wonder if you guys could do this, impacted by 19. This might be another way. So maybe this is something, this is new. I haven't seen this. Not sure. Maybe there's another tool to do. But you can schedule with Pearson VUE right here. And then once you go through, you're going to actually have to create a Pearson VUE account with your information. So make sure that you don't share that with anybody. And once you go through the entire process, I'm going to click out of it because it's going to show my personal information. Once you go through the entire process, at the very end, it's going to ask you for a coupon code. And then that's where you're going to put the coupon code that I sent you. That's where you're going to put that. My encouragement, your coupon code again expires February 28th. So at the end of February, my encouragement is schedule this exam now. Now, it doesn't have to be tomorrow or next week. It could be within a month. It could be within a month and a half or 2 months, whatever you know your schedule. But I would schedule the exam, because if you do that, I have found that students will go and study for the exam. If you don't do that and you have this coupon code, you're like, oh, it doesn't expire until February. I'm chilling. I'm good. And then you don't get around to it, or you try to schedule it at the end of February and then all of a sudden you've forgotten everything. And so if I were you, I would dive into the material now. I would, spend an hour a night going through 1 or 2 things. And then I would schedule it out for 2 to 4 weeks just to make sure I'm ready, take this exam, and then get certified. Any questions on this? You will have access to all of this material. Any other questions?
I have one question.
Yeah, go ahead.
Are the different workshops are any way related, and will they help you with the other exams? Because I scheduled myself for all of them.
Yeah. They are not related as far as will they help you? No. So the DP-900 is different. It talks about more of the structured and unstructured data, how we handle that, how we handle images and videos, how we handle all of that information, how you do like data lakes and using those different tactics. And then the AI is really more of a, the whole morning we talk about kind of a crash course in, it's kind of a crash course in like machine learning. And then the afternoon's really the fun part, where it's the cool tools that you have from Microsoft and Azure, like computer vision and NLP and text to speech and speech to speech, that kind of stuff. So I would say that no, they don't necessarily help each other. So like if you are wanting to do the AZ-900, you won't benefit as far as it's not going to help you on the AZ-900 exam to attend the AI-900, but they both are Azure, if that makes sense. So both the same organization, just different sectors.
Yeah.
Beside the theoretical, the testing and practice, so any operational like videos available to how to use the Azure cloud and deploy this application available for testing, or just the theoretical multiple choice question to pass this certificate?
It's all multiple choice.
Okay. So any video, how to log in the set up the account on the cloud platform and deploy this the application available online or just on YouTube?
Yeah, so there are videos within the Microsoft material as you go through. There will be some videos that kind of can explain a topic. There is one, Free Code Camp does one. So if I do Free Code Camp AZ-900, they have one video. It's 3 hours long. It is just, it's right here. It is, if I'm super transparent, it is just, what is happening? Oh, this is the wrong one. It is, oh, that guy. Yeah. It is just a lot of him saying, and this is this, and this is this, and this is this. Like, this is what this is. And then he shows that. And then, so it's a lot of the topics. So if there is a video, I'll put this as well in the chat. It's a lot of topics. So what I actually like to do whenever I was studying is if I'd go to the gym, if I was on the treadmill or the stair stepper, I would actually just throw this on and listen and just get used to the verbiage of, what is scalability, what is high availability, what is cross cloud, et cetera, et cetera. But this would probably be the other video that I would suggest. Any other questions, my friends? And I'll make sure I send that YouTube video as well. Anything else? Okay, well, guys, thanks for coming to this workshop. Thanks. I hope that you learned something. I hope that it was successful for you. I'm always here if you need to reach out to me. Feel free to reach out to me on LinkedIn. Feel free to reach out to me via email. I'll be sending you an email tomorrow if you guys have questions while you're studying. If you're not quite understanding a topic, always happy to meet one-on-one and kind of walk through that material with you. It's awesome. I hope that you enjoyed this. Did you guys learn something today?
Yeah, I learned a lot actually.
Awesome. Good. Good. I know that your brains have been, you've really been learning today. So go give yourself a break. Go eat some lunch. If you still haven't eaten lunch, please go do that. It is just the beginning, and just know that this is a journey, right? Understanding the cloud is a journey, and you guys have just started. So way to go.